We're in section 1.7. We're talking about solving inequalities. We already looked at a linear inequality and a three-part inequality, and now we're going to talk about quadratic inequalities. You can see a couple of examples here. This first one says x squared minus 7x plus 10 is greater than 0. And so you know that it's quadratic because it has the square on the variable. And the steps to solve this are a little bit tricky. It's not quite like solving the equation. And so what we have to do here is just follow this 5-step process. And well, I guess we'll read through the steps as we go through the problem, and then we'll also try to understand why these steps work and why we need to go through these steps instead of doing something else. Okay, so step 1 just says get 0 on the right side of the inequality, and look, we've already got that, so we can just check that off. And then get a positive leading coefficient on the left side. So the leading coefficient, remember, is the coefficient on x squared, and that's a positive 1. So we have a positive coefficient. And then we can factor the left side, so we should go ahead and do that. We get x, let's see, it must be x minus 5 times x minus 2. And that's greater than 0. And so here we have the factored form. And we've finished the first step in the process. Now the second step is kind of weird. It says just go ahead and solve the corresponding equation. And so again, I'll try to explain why that's so important in a few minutes, but for the moment, let's just go ahead and do it. So to solve the corresponding equation means we need to solve x minus 5 times x minus 2 is equal to 0. And it's a different problem. It's the equation that's going to give us some information to help us to solve the inequality. And once we're already in factored form, then this will go pretty fast. We'll just get x minus 5 equals 0, or x minus 2 is equal to 0. And your two solutions then are x equals 5 and x equals 2. And so we finished with the second step. Maybe I should number the steps out here to the left. This is step number 1, where we just got it into the factored form. There's step number 2, where we solved the equation. And now in step number 3, we're going to identify intervals determined by the solutions of the equation. And so what that means is that we want to draw a number line, and we just need to label the 2 and the 5 on the number line. You could put the other numbers like 0 and 1 and 3 and 4 and 6 and 7 and so on, but that's not necessary. So what we're trying to do, we do need to be careful that 2 is on the left and 5 is on the right, because of course 5 is bigger than 2, and the number line goes from least to greatest, from left to right. So so now the intervals that are between and beyond these solutions, the 2 and the 5, that would be starting at the left end of the number line. You remember that's negative infinity. And then we're going to go up to that first solution, 2. And so that's an interval. And so then the next interval would be from 2 to 5. And then the next interval would be on the other side of 5, all the way out to infinity. And so what we're saying here is that these 3 intervals are candidates for solutions to this inequality. And so what we need to do now is we just need to check each of these candidates, each of these intervals, and see if it satisfies the inequality or not. And so let's think about just why that would be true. Well, we're asked to find, if we look back up here at step 1, we're asked to find when is the product of this number, x minus 5, and this other number, x minus 2, when is that product positive? When is it greater than 0 means positive, right? For any value of x, right, we're gonna have x minus 5 as a number multiplied by another number is going to give you, we want it to give a positive result, a positive product. Well, what else could it give besides positive? It could also give negative, and it could also give 0. And so what we did in step 2 is we figured out which numbers make this product to be 0. That's 5 and 2. And so then what we're saying is that we don't know over here at the left end of the number line if the products are going to start out positive or negative, but we know that they're going to be one or the other, and they're going to stay that way until they turn negative. Until they turn to the other, from positive to negative or from negative to positive. And right in between the positive and the negative, or vice versa, is the number 0. And so when we identify when the product is 0, then we know when or where the product can switch from positive to negative and vice versa. So that's a little tricky. That might be a good thing to think about a little more and to read in the textbook, and definitely to practice. So anyway, let's go on. Let's do step 4. Let's use test values to determine the sign of the quadratic on each of these intervals. And so in step 4, what we're going to do is we're going to make a little table. And we can write interval, and then we can write test value, and then we can write sign of the product we're interested in is x minus 5 times x minus 2. And so those are 3 columns. And then there are 3 intervals that we need to check. So the first interval is negative infinity to 2. And the next interval is 2 to 5. And the next interval is 5 to infinity. And so what we're saying is we don't know what the sign is, positive or negative, on this first interval from negative infinity to 2. But it's always the same sign on this interval. So we don't need to check lots of different numbers on this interval. We only need to check one of them. And then when we know the sign there at that particular point, we know the sign on that entire interval. So pick a number between negative infinity and 2. Any number will do. Maybe the easiest one to work with, or the one I like the best, would be 0. And then on the next interval, pick a number between 2 and 5. Either 3 or 4 would be your best bet, unless you wanted to use a fraction or a decimal. And then a number that's bigger than 5, let's just use 6. Okay, and so then what we're going to do is we're going to check the sign of this product. So in particular, we're going to do 0. We're going to plug in 0 for x, and we're going to have 0 minus 5 multiplied by 0 minus 2. And so that gets us negative 5 times negative 2, which is positive 10. And so the big conclusion here is positive. So the sign of x minus 5 times x minus 2 is positive, as we just discovered. And so then we want to go through the same thing in for each of the test values. So this time we'll plug in 3 for x, and we'll get -2 times +1, and of course that gets us a -2, which is a negative number. And so the sign is negative on that interval. And then finally, from 5 to infinity, we'll choose the number 6. We'll plug it in. And here, let's speed this up just a little bit. What is that? 6 minus 5 times 6 minus 2. So that's a +1. But it doesn't really matter that it's 1. It just matters that it's positive. And then the next factor is 6 minus 2 is +4. Again, it doesn't matter that it's 4. It only matters that it's positive. And we know that we have a positive times a positive. So the result is a positive, which I guess I can write again here to the there to the side. So when we're keeping track of the sign of a product, we don't actually have to keep track of its magnitude, the magnitude of the product, the size of the numbers. Only the signs of the numbers matter. In this first row, a negative times a negative made a positive. In the next row, a negative times a positive made a negative. And in the third row, a positive times a positive makes a positive. Okay, I think we're ready to make our conclusion. Let's double check. So in step 4, we use test intervals to find the sign on each interval. And then in step 5, we're just going to make our conclusion. We're going to state the solution set. So and let's actually look back here one more time. You know, when we look at this problem, this quadratic inequality, what this is asking for is when is the product x minus 5 times x minus 2 positive, right? Because that's what greater than 0 means. Greater than 0 means positive. And so the answers are these two intervals, this interval right here that made the sign positive, and this interval right here that made the sign positive. So in step 5, we can go ahead and write our answer, -infinity to 2. We use a union symbol, make it look a little bit neater, that's good enough. And then the interval from 5 to infinity. You could check that some of these numbers actually work by plugging them in, right? You could plug in a number bigger than 5 or less than 2 into the original problem or into this factored form that we wrote, and you could see that it really does make a true statement. So there's our answer, and we're finished. Let's go ahead and stop this video, and then we'll do this other example in the next video and get a little more practice with it.